What do you do first if you're solving this problem here? Most of the problems are going to end up looking like something like this today when we complete the square. So that's why I want to make sure you guys are comfortable solving something that looks like this. What do you want to do? Move the 12. Good. All right, so I've got this 4 times x plus 3 squared. And what would that be? 400. What should I do after I add 12? What do you think? Yes, don't distribute, you're going to divide. All right, so I get x plus 3 squared is equal to 100. All right, do I want to FOIL? What do I want to do next? Yes, don't FOIL. I saw so many people do this on their quiz. I was like, no. Okay, just you want these parentheses. This is what you're going to want today, okay? Just take the square root, because then you don't have to FOIL, you just get rid of it. And then this ends up just becoming just x plus 3. The square root and squared cancel each other out. You just got to isolate those parentheses by themselves before you take the square root, and then you can just drop them. What would I write on the other side of the equation? So this side would be x plus 3. What would this side become? Grady, what do you think? Yes, please don't forget that. If you introduce a square root into the problem, which we did here, there was no square root when I started this, right? If you introduce that, you have to put that plus and minus symbol, because there's actually 2 possible answers that are going to work there. This would be 10 or negative 10. Now, the weird part of this, I don't have x by itself, so I have to do a little step to move the 3 away from it. Now, my best advice to you, just whatever that is, in this case, I'm subtracting 3. Just write that number immediately after the equal sign, and then you add plus minus 10. Now, if that's a plain number, like this is plus and minus 10, you can actually add those or subtract those numbers, so go ahead and do that. If it has a radical attached to it or an I attached to it, then we're done, but if it's not, we can actually add. So I'm just going to kind of go across the top. So negative 3 plus 10 would be 7, and negative 3 minus 10 would be negative 13. So those are my 2 answers. So make sure if you can, go ahead and simplify that and like take that extra step. Like I said, if the 10 has a radical attached to it, you're done, or if it has an I attached to it, you're done. But if it's just a plain number, you can actually add or subtract there. All right, now, like I said, most of the questions are going to end up looking like this today after we do what's called creating a perfect square trinomial. So I just have a couple examples of perfect square trinomials. These are not equations, they are just expressions that I'm going to see if you guys can factor real quick here. So what would be 2 numbers, like I can factor both of these. What would be 2 numbers multiply to get 25, add to get 10? What do you think? 5 and 5. Okay, so I could write this in factored form as x plus 5 times x plus 5. What is another way I could write that? Yes, okay, so that is what a perfect square trinomial is. Anytime both factors are the same. And what we're going to do when we do what's called completing the square, we're going to create these today in our questions. What would you tell me for this one next to it? So this is x squared, but then this one's minus 14x plus 49. Like, what are 2 numbers I could multiply to get 49 but add to get negative 14? Yes, yes. And you don't have to do these 2 steps. I'm just trying to show you. Both of those factors are the same. That allows you to write it as x minus 7 squared. So the 2 factors could both be positive like this one, or they could both be negative like this one. All right, now, not every question you run into is going to be a situation where the 2 factors are the same. So, and I call this magic number. I don't know if that's like proper math notation or whatever, but this is what I call it. Okay, so in some questions, when we're working with an equation, you might want to create a perfect square trinomial to help you solve the problem. So to do that, if you have ax squared plus bx plus c, and you can identify the b value, it is just the b value divided by 2 squared, and you're going to add this to both sides when we have an equation. But that's all you're going to do, and we're going to work on this. We're just going to create some perfect square trinomials. So we're not going to add it to both sides because I'm not going to have an equation in my first example. But all you have to do Tell me what the b value is. It's just whatever the number is attached to x, and it could be positive, it could be negative, it just depends on the question. But we're just going to take that number, divide it by 2, square it, and if that number, that will be your constant to do that. That'll be the constant term. So that'll be the plain number, and if you have that, you'll automatically have what we call the perfect square trinomial. So we're just going to practice this on these couple questions down here. What is, if I just have x squared plus 20x, what is the b value there? The 20. Okay, so here's all you have to do. If I take 20, and this is just the formula, it's that b value divided by 2 and square it. So 20 divided by 2 would be 10, right? We're going to square it. The actual number is 100. So if you were working with a problem like this, if I had 100 right here in this little blank, then that would be a perfect square trinomial. Can you guys think of two numbers multiply to give you 100 and add to give you 20? 10 and 10. Okay, so I just want to show this to you. So right above here, the factored form of this would just be x plus 10 squared, right? Both of the factors are the same. What I want to show you, because sometimes this can be tricky if you're working with a fraction, which can happen in a couple of these questions. Whatever you square, like I squared 10, that is the number that's in my factor. That will always be the case. And you're going to be like, okay, duh, I could figure that out, but we're going to have a question that has a fraction here in a second, and if you can remember that, that'll make that easier to do. All right, so that's 20. What's my b value in this x squared minus 8x plus? We're going to figure it out, but what's my b value? Negative 8. Okay, now this is important. So the b value is negative 8. All right, now negative 8 divided by 2 is negative 4 squared. But every single one of these, we're always going to square something. Whenever you complete the square, it's always going to be a positive number because we're always going to be squaring something. So what do I get when I square negative 4? Positive 16, right? Okay, so what I was going to show you though, remember what I just said to you, whatever you square is your factor? What I ended up squaring here was a negative 4. So if I was doing this question, I would ask you, okay, tell me two numbers, multiply to give you 16, add to get you negative 8. And then you would tell me negative 4 and negative 4, which we would squish together and write as x minus 4 squared. So whatever you square, I promise you, that's always what goes in the factor with the x. All right, now this is why I'm showing this to you, because this last one's really, really tricky. What is the b value in this last question? Negative 3. Okay, now these other two were both even numbers, right? So I could divide them by 2. In this question, I'm going to take my b value divided by 2 squared, and I can't actually divide that, right? It's a fraction. So you can't square it. It's going to become positive every time. We're going to square the top and the bottom. So if I square the top of that fraction, negative 3 times negative 3 is 9. Bottom of that fraction, 2 times 2 is 4. So that is what I would put here to complete the square. Now, if I sit there and told you, tell me two numbers that multiply to give you 9/4 that add to negative 3, you'd probably look at me for a few minutes before you figured that out. But if you remember what I just told you, I promise, whatever you square, that's what's going to go in the factor. So the factored form of this would just be x minus that 3 over 2 squared. And if you wanted to FOIL that out, right? I'd have x minus 3 over 2, x minus 3 over 2. If you multiplied that out, you would get back exactly what you have right above there. But I promise you that whatever you square, and especially if it's a fraction, that's a good deal to remember that. That's going to be in the factor with the x. Is anybody having a question? Okay. Now this is a little teeny bit tricky. So I am actually going to ask you to find the b value on this question that would make it a perfect square trinomial. So let me just remind you of this. The constant term, if you have a perfect square trinomial, so the plain number, has to be the b value divided by 2 squared, just in general. All right, if you got a perfect square trinomial, the constant term, the plain number, it's 25 for my first example here, has to be the b value divided by 2 squared. Both of these questions actually have two answers. So here's what we have. I have 25, that's my constant. That needs to be equal to my b value divided by 2 squared. Now, in the problem, they represent b with the letter k. So I'm just going to put a k right here. How would you solve that equation to figure out what k is? Okay, take square root. And this is where you're going to get your two answers, right? Because we just introduced that square root. This would be plus or minus 5. Now, that's equal to k divided by 2. How would I end up solving that then to get my answer? Multiply by 2. Yeah, exactly. Just multiply by 2. Now, the deal with the plus and minus, I'm just multiplying it by 2. So then my answer is just going to be plus or minus 10. And if you guys thought about that, if we plug that in, if this was x squared minus 10x plus 25, two numbers multiplied to give you 25 and to get you negative 10, negative 5, and negative 5, positive 10 would also make that a perfect square trinomial. The factored form would just be x plus 5 and x plus 5. So that's why there's two answers. Okay, see if you guys can figure out the k value on this last one. So the constant term, I got 121 here, has to be the b value, which is represented by k in this problem, divided by 2 squared. See if you can tell me, there's two answers. What two numbers can k be for that question to make that a perfect square trinomial? If I've got the 121 as my constant. Yes, good. Should be plus or minus 22. All right. If you square both sides, you can get plus or minus 11, and then multiply both sides by 2, plus or minus 22. So either one of those numbers would work to be k. Is anybody having a question? Yeah.
What would you do with the minus sign to k? Is that not k?
It technically wouldn't. Okay, we could do that. So basically, if we did that, it would just kind of flip it over. You would still have a plus and minus. Actually, that's a really good question. I should have put that in there. But if you would take your plus and minus symbol and divide a plus minus symbol by a negative, you would still have a plus and a minus. But I'm glad you said that. Actually, that's a really good question. But it still could be two answers here. That's a really good question. All right. Now we're going to complete the square. I promise this is not hard. All right, now this method, you cannot always factor, you can't always graph and get nice answers. You can't always take square roots. You can always use completing the square to factor, to solve any quadratic. The one thing I would tell you though is it can be a little bit tricky if your a value is not equal to 1. All the questions we're going to practice today, the a value is 1. So that's the first step. It just says the a value has to be 1. You won't have to worry about that today. We're going to take care of that next week. Now, what I'm going to have you do, I'm just going to walk through this with you in the problems, but this, if you want to go back and look at it, is going to tell you step by step how to do it. All right, so I'm just going to move down to the problems. I'm going to walk you through the process that's written up there. That's really just for you to go back and use if you want to. What I'm going to have you do first, I'm going to keep the squared term and the linear term. So the x squared minus 6x, I'm going to keep those where they're at. And if you have any plain number in your problem, you're going to move it to the other side of the equation. So you want your x squared and your x term on the same side. Any other plain numbers, move it to the other side. Before I do that though, this is just my personal thing that I like to do. I like to put a little spot, kind of like I had on the problems on the front, to complete the square. So I'm going to move that 15 to the other side. It's a negative 15 where it's at. So if I move it to the other side, it's going to end up being positive 15. And then what I do, when you complete the square, when you're working with an equation, you're going to add it to the left side there to complete the square and get yourself a perfect square trinomial. But to keep my equation balanced, I'm going to have to add that number to both sides. Okay, all you're going to do, you're going to grab the b value. So it's negative 6 for this problem. So I'm just going to kind of come in the margin here. I'm going to take my b value. So I'm going to do negative 6 divided by 2, and we're going to square that to complete the square. So just b value divided by 2 squared. So that would be -3 squared, which would be 9. Whenever you complete the square, you should always be adding something to both sides. So I'm going to add 9 to both sides of this equation. Okay, now what I've done is I've created a situation on the left where I can get two factors that are the same. We can squish them together and write them as that factor squared. So I'm going to write this. If you want to skip this step, you can. This is, in factored form, x minus 3, times x minus 3. On the other side here, we would just have 24. The entire purpose of completing the square, I can squish these together because they are exactly the same factor and write that as x minus 3 squared. And then this turns into a problem like we've been doing with our square roots. I'm just going to take the square root of both sides, and square root and squared cancel each other out. I don't want to forget my plus and minus. Now, 24 is not a perfect square, so we would have to break this down just a little bit. Does anybody know biggest perfect square that goes into 24? 4. So I would just rewrite that as 4 times 6 real quick. So take the square root of 4. This would be plus or minus 2 roots of 6, just if I broke down that 24. Now, the nice part of this, all I'm going to do, I'm going to add 3 to the other side, and we're not going to be able to combine it with anything because the other part that's on there has a radical attached to it. So just write that 3 right after the equal sign, and then plus or minus 2 roots of 6. Those are my 2 answers to that question. And I know that's kind of gross looking, but some of these quadratics, they just don't have nice answers. If you want to check, you could actually plug those back in for x in the original problem, and it should set it equal to 0. If I was doing it, I would do that on my calculator. All right, now I'm going to do one more with you. So I want the squared term and the x on the same side, and you want your squared term to be positive. So I'm going to just kind of rearrange this a little bit, and I'm going to add the 16x to the same side with the x squared. I'm going to leave a little spot to complete my square, and I'm going to move the 89 to the other side. So that would be negative 89. All right, now I'm going to complete my square. So I'm going to take my b value, which is 16. We're going to divide that by 2, and we're going to square it. So that would be 8 squared, which would be 64. So 64 is going to complete the square on that left side, and I just got to keep my equation balanced, so I got to add that same thing to the right side. All right, whatever you square, I promise, that's what's in the factor. Multiply to get 64, add to get 16. The factored form of this should be x plus 8 squared. Now, on the other side, you're going to see here, I'm going to get negative 89 plus 64, which is negative 25. So we're actually going to end up with an imaginary answer here because we're going to end up taking the square root of a negative, but we know how to do that. Okay, so we're just going to take square root of both sides. The entire purpose of completing the square is getting those two factors to be the same, so we can just write them as that factor squared, and then we can cancel that out. So I would end up with x plus 8, and I introduced that square root, so I'm going to put plus or minus. What would you write for the square root of negative 25? There you go. All right. Now, all we have to do, we're not going to be able to simplify anything here, but I got to move this 8 to the other side, so I'm going to subtract it. So my two answers, I'm going to have negative 8 plus or minus 5i. Just can't do anything more there. That's going to be my answer. Is anybody having a question? Okay, now I'm not going to lie to you. If the b value is an odd number, like it's going to be in these two examples down here, this is a little bit more garbagey to work with because you're going to have some fractions, but it's not a big deal. You can handle a fraction, I promise. Okay, so I'm going to do the same exact thing. I'm going to take and have my squared term and my x term on the same side. So I'm just going to start out writing that. I'm going to do plus, leave a little blank. And any plain number, I got a 6 in this question. I'm just going to move it to the other side real quick. So if I did that, it would be negative 6. All right, you might want a calculator for this because we're going to be working with some fractions here in a second. It doesn't have to be a graphing calculator. All right, now, anytime that b value is odd, that makes this a little bit more of a challenge. So my b value here is negative 9. we're going to divide that by 2 and square it. I just can't actually divide there and do anything to simplify because 9 is not nicely divisible by 2. So what I would tell you to do there, if you get a fraction, just square the top, square the bottom. The top will be a perfect square. The bottom will always also be a perfect square, but it will always be 4 because the little formula is the b value divided by 2 squared. So this would be 81 over 4. That's what I'm going to add to both sides. All right. Now, as I promised you, all right, whatever you square, for this question, that was that negative 9 over 2. Whatever you square, that's what goes in your factor. So the factored form on this left side is going to be x minus just 9 over 2 squared. Okay, now, scientific or graphing, I'm just going to use my calculator to do this real quick. So if you guys don't already know how to do this, I'll show you real quick. I'm going to take negative 6, and I want this as a fraction. So hang on a second, let me see if I can make it so you guys can see my screen a little bit better. Okay, so I'm going to take negative 6. Okay, now I'm going to put the addition sign. And I'm just going to put this fraction in parentheses. I'm going to just do 81 divide by 4. So I just, 81, hit the division key, divide by 4, I just put that in parentheses. Okay, I'm going to hit enter, and that's going to give me a decimal. You don't want a decimal, and I'm going to show you why in a second. Just hit, and maybe you could convert this on your own real quick, but just if you want, have the calculator do it for you. Just hit the math button. It's the 4th button down on this left side. Just hit math, and then hit enter twice, and it'll convert that to a fraction for you, so you don't have to think about it. And I got 57 over 4. Now, here's the reason that you want this as a fraction, okay? I'm going to take the square root of both sides, and you're like, oh, Miss Grody, this is garbage. It's not that bad, I promise you. We're going to take square root of both sides. All right, now, x minus 9 over 2 left over here. 57 does not break down under a square root. Oops, I forgot my plus minus. What is the square root of 4? 2. Okay, that will always be 2. All right, now on this other side, I'm going to move this fraction, but the denominator of that fraction will always be 2 because it's the b value divided by 2. You square it to add it to both sides, but the factor is always the b value divided by 2. So I'm going to move this by adding it, right? So we're going to have 9 over 2 plus or minus square root of 57 over 2. Can I add those fractions together? You can't, you can't add 9 and 57, square root of 57, but they do have a common denominator, so that's the one nice thing about this. If you want to leave it like that, that is completely fine with me. If you want to, though, you are allowed to do this like 9 plus or minus radical 57 over 2. You could write it like that as well. That's totally legal. I would take either one of those, but that's the one nice thing about this. If you do end up working with a fraction, it'll always be something that you can just add to the other side. It'll just be over 2. All right, now I'm going to try one more. This is a real answer, right? We had a nice positive, well, not a nice positive. We had a positive prime number under the square root we couldn't break down. The one I'm going to do to the next side of this is going to have an imaginary answer, just so you guys could see an example of each. All right, so I'm going to have x squared plus 7x, and I'm just going to leave a little space to create that perfect square trinomial. And this one's going to be a fraction again on this question because my b value is odd. All right, we're going to take our b value, positive 7 divided by 2 squared. Now, I can't actually do anything in terms of dividing that, so that's going to be what's in with my factor, but to square it, I'm going to need to add 49 over 4. That's going to be my magic number that I want to add to create the perfect square trinomial. So I'm doing 49 over 4 to both sides. I promise you, whatever you square, that's going to go in your factor with the x. So the factored form of this left side is going to be x, it's positive 7 over 2, so I'm going to put a plus. When we just did this last question, it was negative 9 over 2, so I had a minus. So this one's going to be a plus. 7 over 2 squared. Now, the other side, again, I'm just going to grab my calculator real quick. I'm going to use my negative key under the 3 to do negative 16 plus, and I'm just going to put 49 over 4 in parentheses. And then, I know you guys could convert these, but I'm just trying to save you some time. So then I just hit math, enter, enter. And this guy is negative 15 over 4. Okay, we're just going to take square root of both sides. So on this left side, I just get x plus 7 over 2. Square root and squared cancel each other out. Now, really on the top of the fraction, you want to just see if you could break that down in any way. 15 is not divisible by any perfect squares, but if it's negative, the way I want to write it, I'm going to put my plus minus symbol. I'm going to write I times the square root of 15 to take care of that negative. And then square root of 4 every time is 2. So you can take the square root of that denominator. The only other thing I got to do is move that 7 over 2 to the other side. So I'm just going to do that real quick. So I'm going to get negative 7 over 2 plus or minus I root 15 over 2. If you want to leave it like that, that's completely fine. If you want to, though, those are actually fractions with common denominators. So I can write it as kind of like one big fraction. You'd have negative 7 plus or minus I radical 15, the whole thing over 2. You can combine those. It's just a little bit tricky looking. Is anybody having a question? Okay, now, I do have the homework assignment for this on Math Excel, and there is a page that's just scrap paper in your homework packet. If you want to use that, you don't have to, but that's in there for you. And it should just say 4-7A when you get in there. It'll be similar to what we did today. Some of the questions just ask you to create a perfect square trinomial and things like that. So that's what we're working on today.